understood anything from yesterday's session, not a problem, right? Because Hadoop starts from today, right? We will be looking at a lot of details, uh, the things which we have talked about yesterday. We'll be doing a deep dive on that, right? We'll be picking up each thing one by one and doing a deep dive on that. So let's start. So these are the key points from module 1. So yesterday, what we talked about or what we discussed about was when to use Hadoop, right? And we, after a few discussion, we came to know these were the main reasons why we should use Hadoop, right? And one of the primary reason was data size. You should have a steady influx of data. And what is the data size I'm going to operate on? And what are the user expectations in terms of response time? As I said, Hadoop is not a real time. So let's say if you are asking for a very quick responses in few milliseconds, then Hadoop is not for you. And what is the shelf life of my data? Means what is the retention period? Right? All these factors will decide. Now, another thing is, other key points were Hadoop provides a distributed file system, right? As we saw in our brief discussion yesterday, the file system will not be specific to any node. It will be distributed, right, across multiple nodes. Secondly, it is a framework. It is not a tool, right? It's a framework for processing data. And another thing, whatever data we write to HDFS, it will divide into smaller blocks, right? Like any other system. Whenever you write a file, even on Linux or Windows, it is broken down into smaller chunks. So this is what we yesterday discussed. So as I was saying, Hadoop is an ecosystem, right? It is not a single tool. When we say ecosystem, it means there will be multiple tools it will have. For example, the main things will be, one will be HDFS. The file system will always be there, right? Unless and until we go to some vendors which will not be using HDFS, but they will be using some proprietary file system. But file system will always be there, right? So this layer of HDFS will always be there, whatever you do in Hadoop, whether you store data, whether you process data, whether you run a database, whether you run a SQL, whatever you do, irrespective of that, storage layer will always be there, which is HDFS. On top of that, I can plug in a lot of things, as I was saying. For example, Hive. So Hive is a data warehousing tool, right? Say, let's say somebody is from a database background. Someone is a database guy, or from a data warehousing. So how he or she can leverage Hadoop? See, it is not necessary that one should know all the aspects of a system, right? For example, a DBA who wants to move into Hadoop domain, he doesn't need to know how Linux works, for example, right? Or how Hadoop works, right? Only basic idea will be fine. What he can do, he can carry forward whatever he has learned in a DBA like SQL queries and all, and use Hive to run the query. So Hive is what it is doing. It is hiding the complexities of Hadoop from a novice user, right? Who might not be aware of what Hadoop is. I can do scripting as well. For example, Bash, Perl, Python you do on a system, but in a Hadoop world, I can write scripts in Pig, right? So when I'm using a layman term by saying script here, actually it is a data flow language, right? So when we go in detail, we will see what exactly Pig is. Another thing is I can do machine learning on top of it. Machine learning means I do not need to reinvent the wheel. For example, Hadoop is very recent, but we have been doing a lot of machine learning algorithms over the years. For example, let's say behavioral targeting, some kind of predictive model, let's say a simple sine or a cosine function, right? How I can use all those math libraries, for example, in Hadoop. So Mahout does that for you. What Mahout does, it writes a wrapper on the existing technologies, and you can use that into your Hadoop platform. And again, we have another tool, for example, Oozie, right? Oozie workflow. It is similar to a cron tab, right? In Linux, we have a cron tab using which we schedule jobs. In Oozie also, we can, in Hadoop, we can use Oozie to schedule jobs, but it does little bit more tasks as compared to cron. We can schedule on time based as well as on conditions. I can say run job A if job B is successful, right? So all these things we will be looking in our course as we go along, but I was just giving you an idea about ecosystem. So yesterday I talked about that there could be a multiple things which Hadoop can contain, right? So Hadoop is not just a file system, not just a map reduce. You can just plug in a lot of things. For example, let's say I'm running a Hadoop cluster. I need to import or export data. I can import data from maybe a simple file, maybe Apache server logs, maybe Twitter feeds. So for that, what I will do, I will use Flume. So Flume is a tool which you will use for unstructured or semi-structured data. Scoop is a tool which you will use for structured data. For example, RDBMS. Let's say you have some database, some table in Oracle or MySQL. You want to import that onto Hadoop, you will use Scoop, right? So I'm just giving you a glimpse. There are hundreds of tools. Every day in the market, new tool comes up. So all these things we will be looking in our course, right? So agenda for today's talk is we will be building upon what we have talked yesterday. So yesterday we just touched upon Hadoop. Mostly we talked in theory, but today we will be doing a deep dive, the technical aspects, deep dive, and look what each thing is. So agenda will be, we'll be looking into little bit more details of HDFS. We'll be looking at how name node and data node talk to each other. We'll be looking at some aspects of how things go in the backend. And most important, today we will be setting up a Hadoop cluster. We will look at what are the important config files, what things you need to run a Hadoop cluster, what all modes it runs in, right? So as we will be going in the course, our cluster will keep on growing, right? So it is very important. Today's session is very important to understand how you set up Hadoop, because all other sessions will depend upon this, right? Anyway, recordings will be available. You can watch it again at your convenience, but please pay attention. Ask as many times as you want. Concept should be clear, right? So now let's start with the Hadoop now. So Hadoop is mainly divided into two versions, right? It is not like any other software version. For example, let's say I may have an Oracle version 9, then Oracle version 10 comes, right? With some more features, right? And I upgrade from one version to another, right? Here the issue is one is the major number, right? Let's say if I'm going from 1.1 to 1.2, it is fine, right? There are not much changes in the feature. But if I'm going from 1 to 2, it's altogether a different platform, right? So we will be covering both. So we have Hadoop 1 and Hadoop 2. So when somebody says that he's running Hadoop 1, it means he's running MapReduce version 1, right? This is how the original Hadoop started. Then when people started running Hadoop in production, lot of challenges came up. Hadoop was enhanced, a lot of features were added, right? Then a new version came into picture, which was Hadoop 2.x, means 2.1, 2.2, 2.6. For example, the latest is 2.7, but we will always use a stable release in the production, which is 2.6, right? So we will be doing in our course all these things, right? All versions. So the new version is called Yarn, right? So for the time being, Yarn stands for yet another resource negotiator. But we will look into details as we go along. So now the important thing is we will be doing both the versions in the course. Why? Because still many companies use Hadoop 1, and you need to understand Hadoop 1 to understand the Hadoop fundamentals. Because Hadoop 2 is little bit complex. If I start directly with Hadoop 2, you will not understand why things are happening that way. We'll start with Hadoop 1. build the fundamentals. Then we will understand what challenges Hadoop 1 has. Why does not it scale beyond a certain point? Then we will go to Hadoop 2 and you will see how beautiful platform Hadoop 2 is, right? As compared to Hadoop 1. Let me see if anybody has any questions here. Okay, no question. So we have a new joinee, Manish. Welcome to the session. So Manish has been in this industry for quite some time, more than 15 years of experience. He is a DBA and working on a lot of data warehousing tools, application design, a lot of things, right? So as I said, as the goes along, and we will have different set of people in the audience, people will ask different set of questions, right? So it will be really good to interact, see from different aspects, from a developer aspect, from a system engineer aspect, from maybe some DBA, right? How they see each problem. So all okay, let me just uh, rem- remind everybody once again. So all the participants, they will be in listen only mode, right? They cannot talk, but if they want to, sometimes I can unmute them, they can talk, but mostly as we are recording, to keep the noise low, I will keep them always on mute, but they can type in anytime and I will take the questions. Okay, so now the question is from Shiva is, could you please give more insight on structured and semi-structured and unstructured data? Okay. So let me give an example. What is a structured data? What is a semi-structured data? Or what is an unstructured data? Right? First of all, structured data, right? RDBMS is an example of your structured data, right? RDBMS is your structured data, right? Where you define a structure, you define your schema pre-hand, right? You cannot say insert a data if you don't have a schema for it. You have relationships to query data, foreign key, private key, right? Those kind of things, right? These are all structured data, right? The traditional databases, any RDBMS, whether it's MySQL, Oracle, DB2, whatever, they fall into structured data. Now, unstructured data and semi-structured data. Unstructured data is text file, email, PDF. All these are unstructured data because they don't have any structure. People can write anyway. Some might give one space, two space, somebody might enter any way they want, right? There's no structure to it, right? Anybody can write any font, any size, any spacing, any delimiters. Third type is unstructured data. Oh, sorry, third side is semi-structured. So semi-structured sits between structured and RDBMS. For example, best example is XML. It's a semi-structured data where you do not explicitly define your rules. You can write your explicit tags, but still there's a structure to it, right? You will say, okay, opening tag, closing tag, right? You will build up a hierarchy, right? So this is unstructured data. Now, so yesterday we saw two important components, right? One was HDFS, which is the file system, and another is MapReduce, right? So when I say we saw, I was just giving you a overview or a feel of things, right? But let's do a little bit deeper aspects into it. So as I said, every system which is running Hadoop will always have a file system, right? Storage layer. Others are optional. Even MapReduce is optional. I can use Hadoop only as a storage system, means just to store data. But it doesn't make sense, right? Because data is of no use if you cannot process it or if you cannot work on it, right? So MapReduce will always be there, right? And storage will always be there. So two important components we will start with. One, first of all, HDFS. So it is a file system with high throughput, and it is a storage layer, means it is your storage wherever your data goes. MapReduce is your programming model. It is the brain of the system, right? So we'll take one by one, right? Let's start with HDFS. First of all, Hadoop is a master slave model. What does it mean? There will be a master and there will be a slave for each layer. So as I said, there are two layers. One is file system layer, which is storage layer. Another is MapReduce layer, which is programming model. So there will be two layers and both will be in master slave mode. So for the storage layer, we will have a master which will be name node, slave will be data nodes. For the MapReduce layer, your master will be job tracker and your slave will be task tracker. So for example, in the diagram I have depicted, I will put up a one physical box. Although I can put everything on one box, means your name node, data node, job tracker, task tracker, everything on a single node. But it will be kind of a test machine, right? Which we will do today. But in your production, it will run in distributed mode, means all masters will run on separate physical servers. All slaves will run on another server. For example, I will put up a box. I will configure it as a master for storage as well as MapReduce layer. So both my name node and job tracker will run on one server. And your slave nodes will have your data nodes, that means data node daemon, and task tracker running it. So task tracker and data node will always run on the same node. Here I have a choice. I can run independent servers for each master. What does it mean? I can run one name node on one server, job tracker on another server. But I will always run a data node and a task tracker always on the same node, right? I will run it always on the same node. Why we will do that? I will tell you as we go along, right? Why task tracker and data node will always run on the same node. It is not that I cannot make them run separately. I can do them, right? It is up to the configuration we do, but it will not be the right thing to do, right? So we will see that. So now let's start with storage part, which is your HDFS layer. So in HDFS layer, as I said, we have name node, data node. So yesterday, as I was giving you a brief introduction, name node is the master and it will store all your metadata. And your actual data will go on data nodes, right? So this is what we discussed yesterday. So for people who are joining today, so what I explained yesterday was what happens in traditional file systems, whether it's Linux, Windows, whenever I write any data, the metadata and your actual data resides within the same system, right? For example, I write a file1, the metadata, which is, let's say, the file allocation table we called fat in Windows or inodes in Linux, they will be sitting in the same system as your data. But in the case of Hadoop, your metadata will be sitting on a separate node. We called it as name node, right? And your actual data will go on data nodes. So yesterday we looked at what name node does, right? So name node stores two types of metadata, right? So what are the two types of metadata? Can anybody recall from yesterday's session? Let me clear the screen and we'll start, because this is very important to understand and to build your base for your entire course, right? If you have any questions, please feel free to ask. So let me ask, what are the two types of metadata name node has from yesterday's class? Okay, so Raiguru is saying bitmap. Pawan is saying FS image and edits. Okay, right. So my question was, what are the two types of metadata we have, right? So two types of metadata are, one is the file metadata, another is your bitmap metadata, right? There are two metadatas. So it is, I'm not talking about what files we have, right? I'm not talking about whether I have, let's say, a journal or an FS image. I'm talking about two types of metadata which a name node has. So what are that, right? So very important to understand this. Let me start that once again today. So as I said, let's say I have a file, file1.txt. What will be a metadata of this file? Who is the owner? What are the permissions of this file? What is the timestamp? What is the size of the file? What will be the replication, right? I will come to this later. You can forget this for the time being. Then it will say what all blocks a file has. Means it will tell me a mapping saying, okay, this file has these blocks which are B1, B2, B7. This is one metadata. We called it as file metadata. This is always persisted to disk. Means whenever you shut down your node, your master node, it will be persisted to your disk, and it is also occasionally also being updated, constantly flushed to the disk, because if we start keep it only in the memory and if your machine fails, you will lose data, right? Your file system will be corrupt. So it will always keep on going into a journal which is edits, and that edits journal is always committed into FS image, right? So these are the two files which we will see a name node will have. So it will be persisted on disk. But another metadata it will have will be bitmap. What is bitmap? It is a mapping between block and data nodes. It will say block B1 is on data node 1, block B2, let's say, is on data node 3, right? Slave 3, right? So this metadata is never stored on disk. It will always be in the memory of the name node, right? And very important to understand this, right? So I will explain you a lot of things which are related to this, why this was done that way. So now this is what it is explaining you. Two types of metadata, file metadata and the mapping between the blocks and your data nodes. So the key points which you should remember is only the file system metadata is persisted to disk. The mapping between the blocks and the data node is never persisted to disk, right? Every time data node starts, it will advertise what blocks I have, and name node will build the bitmap. So name node will say, I have received block B1. It has come from data node 1. It will map it, right? So the bitmap will be something like this. So it will say block 1 is on data node 1, 2 and 4. Why? Because each block is replicated 3 times, right? So I will come to replication part, but for the time being you will think a bitmap will be something like that. Each block will be mapping to which data node it is on. So let's say, so yesterday I kind of give you a homework asking you to think and come out with an answer when I said the size of your cluster will depend upon this amount of memory you have on your name node. How? Right? So I explained you a little bit yesterday that everything in Hadoop is an object, and to store or represent that object, it needs some memory, right? It will acquire some memory. So obviously, memory will be the limiting factor. How many objects I can store in a memory at a given time? For example, let's say if I have a data node with 1 TB disk size, and my HDFS block size is 64 MB, right? Which we have explained yesterday, but I will again go into this detail today. So it will have these many blocks. So these many blocks will be advertised to the name node. So name node will know data node 1 has capacity 1 TB and it has these many blocks. Now, name node keeps the entire metadata namespace, right? What is namespace? Namespace is simply a file structure, file system data structure, always in the memory while it is running, and it will always at the same time it will keep on persisting it to a journal and to the disk. Name node records the changes in the HDFS in a journal, right? Which is called edits, similar to a MySQL bin, right? Whatever change we do, it writes into a journal, then it is committed to a database. The location of the block replicas are not part of the persistence checkpoint, right? As I said, name node will not know, no, will not persistently store the mapping between a block and data node. So these are the two files a name node will have: fs image and an edits. The inodes and the list of blocks that define the metadata of the name system is called an image, right? So let's say somebody says, what is an fs image? Fs stands for file system image. So it is simply an inode structure, right, for your name node. So each transaction we do will be recorded in a file called edits, and there will be a file fs image which will never be changed by the name node unless you reboot the machine or you do a checkpointing process, right? So we'll see what is that checkpointing process. So thing is, let's say if my cluster is up and running and I keep on writing data, my edit file will keep on growing, means my journal will keep on growing, right? And it will only commit to fs image whenever I restart or I do a checkpointing. So let me explain you this, what this statement means. Okay, let me clear the screen now. Let's say my Hadoop cluster is up and running and I have a file which is edits. It's a journal similar to a bin log, and I have an fs image, right? So fs image is the image with which my name node will start very first time, and that fs image will not change. Why? Because whatever writes, deletions, whatever I do, they do not go into fs image, they all go into an edits journal. So this journal will keep on growing, right? It will keep on growing during the life of the cluster. So let's say it might grow very big, 10 gigabytes, let's say, right? So what will happen? The next time when I restart my name node, right? What will happen? It will try to commit this journal into the fs image file. So name node will take longer time to start up because it has to empty this file. It will empty this file into this file, right? But unlike database, what databases do? You write into a bin log journal, a sleeping daemon will wake at the background, take whatever was in bin log, commit to the database. But here it is not the case. Edits will never be committed to fs image unless and until you restart your name node or you do checkpointing. So checkpointing is a process of emptying edits journal to fs image, right? So how checkpointing happens, we'll see that, right? So checkpointing is a process of committing your edits to fs image. So this is what it is saying. So whenever a name node is started, it will read fs image, read edits, and commit the edits. Whatever changes are in edit, maybe a block addition, deletion, file deletion, whatever, it will do that changes to fs image, commit it, empty the edit journal, and start with the new fs image. So fs image will never be modified during the running time of the name node, right? Right. So this statement, for the time being, you just take this statement that it will not be modified during the running time of the name node unless and until checkpointing happens, right? So I will tell you what checkpointing it and how it happens. So now the key points here is, as we discussed yesterday, HDFS block size by default is 64 megabytes in Hadoop 1. In Hadoop 2, it is 128 MB, right? So whenever I write a file to HDFS, it will be split similar to any file system, right? For example, even if we write a file to Linux or Windows or whatever, I write a file, how small it might be, let's say 1 kilobyte. It will be split into smaller blocks depending upon the block size of your file system. So in Linux, ext3, ext4, whatever we use, the maximum block size could be 4 kilobytes, right? 4 kilobytes. So similarly in Hadoop, this has become 64 MB, right? So what will happen? Any file which I write to HDFS, means to Hadoop, will be split into blocks of 64 MB, right? So let's say if I have a file whose size is 128 MB, that file will be split into two blocks on HDFS. Every block is replicated 3 times by default, right? So I do not need to put any kind of a RAID in a system, means redundant array of inexpensive disk. I do not need to mirror my disk. So whatever data I put will go at 3 places. So let's say I write a file which is split into two blocks, block 1, block 2. Block 1 will be replicated at 3 places, means it will be at 3 data nodes. Block 2 will again be at 3 places. For example, let's say I have a file called foo. It has, let's say, block 1, 2, and 4. So block 1 will be on this node, right? Here the replication has been shown as 2, right? But the by default replication will be 3. So block 2 goes here, goes here, right? It will never be replicated on the same node, right? It does not mean, let's say a system has 4 hard drives, one block will go in hard drive 1 and a copy will go in the another hard drive. No, it will always go on another system, so that if that node fails, I still have data somewhere else. So replication is of what, right? It is very important to understand. Replication is of what? Replication is of data, not metadata, right? Some people say or confuse that the metadata of the name node is also replicated. No, I have a name node which is master, which is holding metadata. I have data nodes, let's say 4 data nodes. I write two blocks, let's say block 1, block 2 to HDFS. The metadata of this will be written on name node. Let's say it will say file1.txt only once. It is never replicated. Let's say name node says block 1 goes here, block 2 goes here. Then each block will be replicated thrice, means it will be at 3 places. One is already here, it will say, let's say put it here, right? It will say, okay, let me put it here. Similarly 2, it will put it here, let's say it will put it here. So each block is at 3 places. So if this fails, I still have data. If this fails, I still have data, because it is at three places, right? But if this fails, it is an outage. So name node is a single point of failure, right? In Hadoop 1, right, we are starting with Hadoop 1. There is only one master. If it fails, my cluster is down. Although my data is there, blocks are there, but metadata is here. I have no way to reach it, right? So my cluster is down. Okay, so Shiva is asking, if I have 5 data nodes, for example, it will replicate to 5. No, right? No, right? So the point will be, by default replication is 3. Means irrespective of the size of your cluster, it will be only replicated maximum 3 times, because it does not make sense. Let's say if I have 100 node cluster, and if I replicate data 100 times, I will run out of space, right? So there's no point of running a 100 node cluster, right? So what will happen? By default replication is 3. Let's say if I have only 2 data nodes in my cluster, and I do not change the replication, which I can change, but by default it is 3. Whenever I start my Hadoop cluster, replication will be 3, irrespective of the number of nodes I have. Let's say if the number of nodes, let's say denote by n, is less than the replication factor, means the number of data nodes I have in my cluster are less than the replication factor, it will throw me a warning in the messages, right? If you do fsck, right, similar to a file system check on name node, it will tell me a warning saying under replicated block. So it will copy one block on this node, another block on this node, but third block, it has no other data node to copy. So if I go and look into the log and run fsck, it will keep on giving warning saying under replicated blocks. Why under replicated blocks? I have set replication 3. I have set name node to replicate 3 times, but I have given it only 2 data nodes. So it will keep on giving warning. But if I have more data nodes, still maximum it will be 3 times. I can change it, right? There's a parameter I will tell you, right? There's a parameter which I can control, which controls how many times each block will be replicated. So whatever file we write, it will be split. So it will be split like this. I have a file, it will be split into smaller blocks, each block 64 MB, and written to data nodes. And that change will be recorded by your name node in the memory, and also persisted to edit logs, and edit logs rolls back into fs image, right? Edit log is rolled into fs image during checkpointing. So now coming to the discussion which I said I was doing yesterday, and I gave you a kind of a homework. How I decide the size of my cluster, or how can I say how big my cluster could be, right? So this is I explained you yesterday. So if I have a file whose size is 128 MB and HDFS block size is 64 MB, means the HDFS file system block size is 64 MB, the file I write will be split into 2 blocks, right? So now, as I said, in Hadoop, everything is an object, because it is based on Java object oriented concepts. Hadoop, the native code of Hadoop is Java. Everything is an object. Every file I write to Hadoop is an object. Every directory I create is an object. Every block which is created on Hadoop file system is an object. Each object occupies 150 bytes of memory in the name node to represent it. Means the metadata to represent one object is 150 bytes. So now I have two blocks, one block 150 bytes, so two blocks 300 bytes plus one for the file name itself. So I have 450 bytes. So if I want to write a file, file1.txt on a HDFS file system, its size will be 450 bytes in the memory of the name node. Correct? So I will divide the memory I have available on my name node by the block size of my Hadoop cluster. It will decide how many blocks I can have. That will decide the size of my Hadoop cluster, right? So now here, this size which I'm talking about, it's only for one replica. As I said, each block is also replicated three times, right? Total replica is three, means each block is at two more places. So this number is only for one replica, correct? So what is added to this is 16 bytes, right? So file name will not change, right? Because now what it will do, let's say if a block is replicated three times and I have a file, file1.txt. Now it is replicated, what it will say, one object will be for it, whose size is 150 bytes. Now it will say, I have block A, block B2, right? 150 for this, 150 for this. These two blocks are at two more places. This block is at two more places. This block is at two more places. But all are pointed by one file name. So this takes only 16 bytes, right? Only 16 bytes. So how the calculation goes now? Each object, block object will have 168 bytes of memory in the name node for three replication, right? Three replication. So it will be 168 plus 168 plus 150 will be the number, the memory which it will take in the memory of the name node. Okay, question from Rai Guru is, every file is replicated three times. So when file is MB and HDFS block is MB, number of blocks. So both blocks will be replicated across available node. If we have five nodes, across which nodes we will have the replicated data. Okay, see, that is decided by name node, right? So how the this replication is done, right? There's an algorithm for it, right? So which we will see. This is a rack aware algorithm. What it does, let's say I have large cluster, let's say 100 nodes, and I'm running a name node. So what is the main job of name node? One is it will keep block mapping, right, which we have discussed. Other thing will be it will try to balance the cluster, means each node should have equal amount of data. So whenever we are writing a file, name node is making sure, name node is keeping a track of which block is where. So it is equally balancing. So let's say if it is sending some data here on this node, data node, this data node, right? And it knows this two data nodes have data. Next data it will send here, some other places, so that there's an equal utilization of data across your cluster, right? But how it decide where it will go, there's an algorithm which we'll see probably next class or next to next class, right? Which comes under rack awareness algorithm. For the time being, we will not touch that, otherwise it will become very complex. Okay, now how the communication happens between a name node and a data node, right? Let me explain you on the whiteboard. Let's say I have a name node. I have a data node, right? First of all, what I will do, first of all, I have to format the name node like any other file system, right? Whenever we create a file system, we format it. So name node has a file system HDFS, right? Which is laid across all the nodes in your Hadoop cluster. So first of all, what I have to do is I have to format the name node. I will execute a format command, right? So I will see what command it will be, but I will format the name node. The moment I format a name node, it will give it a cluster ID, right? It will be a randomly generated number. Let's say it gave 1, 2, 3, 4, 5, 6, some number it gave it, right? This is the ID, it is the cluster ID, which will decide which cluster. This is kind of an identity of your cluster. Now, I do not do any format on data nodes. I will simply go start a data node and I will tell data node, this data node, let's say D1, where is name node. I will tell it where is name node. I will give the address of the name node in a config file. This name data node will go and try to register itself with the name node. Correct? So if, as I said, these all are new nodes, this data node will not have any cluster ID because it's a new machine which we have built. So what happens when a request is sent from a data node to register with a name node? First thing name node will check is whether this data node was already part of any other cluster, right? Means how it will check? It will check, ask the data node to give the cluster ID. If this data node was never part of any cluster, it is a new machine, so obviously it will not have cluster ID. So data node will say, I am new, I do not have any cluster ID. So name node will say, okay, fine, then you can join me. It will give the cluster ID, same cluster ID. So now this data node will become part of this cluster because now it will also get a cluster ID, same for all. But let's say this machine which I brought a data node, let's say data node 4, was already part of some another cluster and had some cluster ID, let's say cluster ID 7, 6, 8, 9 something. It goes and tries to register itself with the name node. Name node will say, give me your cluster ID. It will send because it has. Name node will say, no, cluster ID does not match. It will fire a shutdown command. Name node will fire a shutdown command on the data node and this data node will shut down. So this is all safety mechanism built into Hadoop. Otherwise, let's say somebody might have mistakenly added this data node into a wrong cluster and it will wipe your entire data. So it is a safeguard mechanism against that, right? So it will not let you do that. So this is what I'm explaining here. So how the communication happens? First is data node will do a registration. As I said, it will say, okay, I'm a new node or my cluster IDs matches and all. Second, it will send a heartbeat every few seconds, which is 3 seconds. It will send block reports and it will also acknowledge the blocks received, right? What does it mean, right? Let me explain you this also. Let me clear it. Let's say I have a name node and I have a data node. First thing is it will register with the Hadoop cluster, right? First thing is it will register with the Hadoop cluster with the name node. First step is register. So it got a cluster ID, became part of the cluster, it joined the name node. Second thing, every few seconds it will send a heartbeat to the name node. Blue line is a heartbeat. Heartbeat is sent every 3 seconds from the data node. It is kind of giving it attendance, right? All those people who are from infrastructure background, it is similar to a cluster heartbeat, right? So the node is telling I am alive, I am there. Every 3 seconds it is telling name node I am there, I am alive, right? This is 3 seconds, every 3 seconds. Another thing which it will do is, let's take green color. It will send a block report. Each data node will send a block report. This is block report. What is block report? It will tell what blocks I have, what is the disk size I have, right? This disk might have, let's say, 1 terabyte disk. This might have, let's say, 4 terabyte disk. This might have, let's say, 10 GB disk. So it will tell the name node, I have so many blocks. So this block, which I'm talking about, the green line, it will send a block report on 3 occasions. First time when it boots, right? First time when the data node boots. I build my new cluster, start my data node, or even when I restart the data node, whenever the data node daemon comes up, it broadcasts or it advertises, not exactly broadcast, it advertises all the blocks it has. Second time, it does periodically, which is configurable, means I can say after 1 hour or after 4 hours or 6 hours, again send the block reports. Third will be whenever a name node asks. Name node can ask a data node saying, give me the block report, right? 3 times it will send a block report. Let me see anybody has any question and then I will go a little bit deeper. Any questions you have up till now? Okay, so no other questions. So let me explain you a little bit deeper. So when I say block report, right? Obviously, like we cannot cover everything in the course, but there are a lot of details which go into it, right? So you will get to know many things when you actually work in a production environment, and you will say, "Oh, I was never aware this also happens," right? But let me give you some little bit idea about it. When does a block report is what type of block reports are sent? First of all, as I said, data node will advertise the blocks it has 3 times. One, when it boots, it will send a complete report of the entire block it has. Second block report it sends periodically, means it is a configurable parameter. By default in Hadoop 1, it is 1 hour. In Hadoop 2, sorry, H2, it is 6 hours, right? I will show you all these parameters. Do not worry, right? Where all these parameters go, how you configure and all, everything we will see. So periodically, so every 1 hour, it will send a block report, but it will not be a complete block report. What block report it will send? Only the delta, whatever blocks have changed. It might be new additions, it might be deletions, it might be corrupt blocks, right? Only delta it will send. Third will be whenever a name node asks, name node will ask a data node, send me a block report. And then name node will say, I want a complete or a delta report. It can send either. So there are 3 occasions when a block report will be sent. Now, little bit more details. If you might have noted, you might be thinking I am just drawing an arrow like that. I'm saying name node, I'm saying data node. D1, D2, D3, and my arrows are drawn in this direction, right? It has a meaning actually, right? It is not that I'm just drawing because I'm feeling it comfortable drawing upwards. What it is telling, it is telling me the direction of communication. What it is telling, that data node is the one which always initiates the connection in terms of communication between them, right? Because I may have thousands of data node, name node is only one. So if I start doing pull mechanism, for example, if I would have coded this way, let's say I have written a Java program. Anyway, this works on RPC calls, right? Remote procedure call, the protocol which talks between them. Let's say I'm a developer and I write this infrastructure first time. What I say, the code which I write over this, right? So anybody who is from networking programming, they will know that this concept is called RPC stubs, right? Skeleton skeleton stub model. So I might have written, I am saying to name node, go to each data node, fetch the blocks, right? If I have 2 3 data nodes, it's fine, but my cluster can be 3000 node, 4000 node. So I'm telling a single node to go to 4000 nodes, fetch the report from all. This will be a bottleneck in my case. I am not doing that design. So what my design is, I'm doing a advertisement from data node, and name node is just listening. It is listening for all the traffic which is coming to it, right? Now name node, data node, D1, D2, direction is this. Now I'm also said that every 3 seconds this data node will send a heartbeat to the name node saying I am there, kind of attendance. In this heartbeat channel, right? If name node has to fire any command, it will fire, right? You got the point? Name node will not open a command channel by itself, right? There are some cases it will open. I will talk that little bit later. But for the time being, name node will never open any command channel to a data node. What it will do, to save on the overheads of opening and a closing file, what it will do, because heartbeat is coming every 3 seconds, it's not a long time. When a data node comes and opens a heartbeat channel every 3 seconds, on the same open channel, it will fire a command to the data node. Any operation command. Command could be shut down data node. It might ask a data node to replicate a block, delete a block, right? Commands could be anything, right? So this is important to understand, right? From a design perspective. A lot of things are there. I will show you some production use cases. When your name node will fail to boot up, if I start all my nodes, let's say I have a 3000 node cluster and I start all in one go, my name node will hang, right? So how we do that, why it hangs, we will look at all those details, right? But this is important to understand, right? What is the communication path? What is the steps it does, right? So this is what I explained you. First step is it will do a registration. I explained you all this which is given in the slides. If name node is new, if the data node is new, it does not have a cluster ID, it can straight away go and join, right? So I will show you all this on the system, right? Do not need to worry where it file is and all, right? Data registration process. Then heartbeat process. So as I said, name node will fire any command in response to the open channel. It might say replicate, invalidate means delete a block, or ask for a block report. Data node sends the block report, step 3. As I said, when it starts, every hour or 6 hours in Hadoop 2, or whenever a name node asks for it. Point 4, Data node will also acknowledge any blocks it has done operation on. For example, there might be a block written to a data node, but it has to acknowledge it to the name node saying I'm done with my operation. Or delete a block, it will update the name node, right? So it updates the name node, other data nodes, or a client. The communication channel is RPC. Client does not talk on RPC channel. Why it does not talk? There is also a technical reason, right? So we will go into in depth of this, right? RPC channel is for communication between the name node, data node, job tracker, task tracker, all these daemons. But data flow does not happen on RPC. Data flow always happens using REST API, right? Because it is light, just do a post and get. What does it mean? Now you will ask how it can do a REST API when there's no web server. So I will come to that. Each daemon, name node, data node, job tracker, whatever we run, will have a web server built into it, into a daemon. We don't need to configure it. It is not an Apache web server or a Tomcat web server. They are full-fledged web servers, right? These daemons, they have a simple JT server written in Java, which can simply do post and get request. So your data transfer will always happen on that channels, right? But your communication saying talk, shutdown command, block report, talking about each other's daemons happen on RPC. So these are the key points. Namespace ID or the cluster ID, right? It has two names. Namespace ID we started calling in kind of Hadoop 2, but it is the cluster ID, right? It's the same thing. Is assigned to a file system when it is format, and it does not change throughout the life of the cluster. If I change the cluster ID, my services will shut down because they will not identify that I am part of this cluster. Heartbeat will be done, right? As I said. So why a handshake is done, right? Why a data node register? As I explained you, to make sure that it is not by mistake attaching to some wrong cluster. Otherwise data will be deleted. And it is also making sure data node is also running on a compatible software version. It is, should not be that I'm running name node with 1.2 version and data node with 2.2 version. It will not let you talk, right? It will fire a shutdown command to safeguard against human errors. Obviously human errors you can do, you can still do rm-rf on a data, right? But from a Hadoop perspective, it is trying to safeguard the common mistake which an engineer might do. Cluster ID will be stored on all nodes so that they know which cluster we are part of, right? As I said, any new data node will be allowed to register with the name node and receive a cluster ID. So okay, I think we are almost in the middle of our class, so let's take a quick break and let me see anybody has any questions. Okay, so no questions. So let's take a quick break of 2 to 3 minutes, grab a tea, coffee, and come back, and then I will start little bit ahead, go ahead of this, and then we'll start moving into little bit practical aspect, starting of Hadoop cluster, setting up of node, data node, and little bit of map reduce, right? So let's take a break and then I will continue. Okay, so let's resume. So there are a lot of details, right? So we will see a lot of things as we go along, because if I overload you with a lot of concepts at this point, it might be confusing. So we will see a lot of things as we go along the course. So on this slide, what I'm trying to explain you is, unlike your traditional file systems, right, where let's say if I'm writing a file which is smaller than the block size, let's say my block is 4 kilobytes, this is the smallest allocation unit, right? And if my file is 1 kilobytes, it is written here, occupy some space. This space which is left, it is unusable, it cannot be given to another file or another block. But it is not the case with HDFS. In HDFS, the file size or the block size will be actually equivalent to the data, right? The size of the data file, right, in Hadoop which you write, will be equivalent to the length of the data, right, and does not require an extra space to round it up to the normal block size, right? So I will show you that what does it mean. So whenever a file is written onto a data node, why it is file, why I'm saying file here, all up till now we have been saying block and all. So let me explain you. I will show you on the system, it will be more clear. So on each data node, obviously, when I create an HDFS file system, underlying file system will anyways be your native Linux file system. Let's say it is ext3 or ext4, whatever. Whatever data I write in HDFS, it will be a block. But this block will be written to a lower file system as a file. What does it mean? I can go from a Linux system directly bypassing this and look into that. I may not be able to exactly make sense of that data, although if it is a text file I can make sense of that, but at the lower level it will simply be a file, right? At the HDFS will see it as a block, and it is written to a lower level as a file, and each file will have another file associated with it, which will be a checksum file, which is called MD5 hash of that, right? So I will show you this on the system. So now, enough of storage part. Now quickly look at the other part, the brain of the system, brain of the Hadoop. MapReduce, lot of things have come, Tej, right? Lot of different ways of computing, but MapReduce is the most native programming model to Hadoop, right? So it is very important to talk about and understand how it runs. So as I said, we have two parts. One is storage layer. You see a that dotted line in between. The lower part is the HDFS layer, which is your file system layer, where I have a name node and a data node. I have a master slave combination here, right? Name node is a master, data node is a slave. Similarly, I will have a MapReduce layer where I will have a job tracker as a master, task tracker as a slave, right? Two layers. So now I will be looking at MapReduce part, MapReduce architecture. So what is actually a MapReduce? It is a programming model which is independent of your programming language or platform. Doesn't matter, Python, Java, whatever you use, you might run a Hive query at the backend, it might do a translation to MapReduce, right? It is a programming model. It has two phases, map phase and a reduce phase. As simple as that, right? So what is a map phase? Map phase is a phase which will map to a data set. Means, let's say I write some data on HDFS and I want to work out on that data, some processing, word count, anything. Obviously I need to read that data. So I will map a function to that to read that data. That is map. Reduce is I might be doing filtering, summation, and writing a final output. I'm reducing that data, right? Lot of details into this we will see as we go along. But let me explain you simply what is map reduce with a very simple example. By default, there will be a map function and a reduce function in map reduce programming, right? A lot of custom functions will be there which you can write, lot of phases in between, right? When I say map reduce, these are not the only two phases. There are a lot of phases in between: shuffle, sort, compression, right? Which we will see little bit later in the map reduce lecture, right? Which will be, I think, the third lecture in detail. But let me tell you from a Hadoop perspective, because we will be setting Hadoop cluster. So you should understand what exactly MapReduce is, right? Details we will do in our next class. So let's say I have a block of HDFS, which is 64 MB. It is containing some data, some data. I need to work on it. So first of all, any data I need to process must be on HDFS file system. It cannot go and read on ext3 or ext4. Means data should be loaded into Hadoop. So let's say I've done that. I've copied it. Data is sitting in my Hadoop cluster and I need to read and work on some data. What is map? Map is a function which will map to one HDFS split. Means if my HDFS block is 64 MB, one mapper will be assigned to it. If it is 128 MB, again one mapper will be assigned to it, right? It will not depend upon the size of your data. It is depending upon the HDFS split. One mapper per one HDFS block. It may be 64 MB, it may be 128 MB, it may be 2 GB. But obviously we need to tune it, right? We will see a lot of details in tuning part, but it will map to one block. So what it will do? Map, as the name say, it is mapping to our data, right? Now, let me give you an example now. Map reduce is a key value pair. It says everything is a key which, and each key will have a value associated with, or you can say other way, every value associated will have a key with it, right? So what it is, let's say I have a simple text file. Simple text file. In that text file, let's say I write hello, how are you? Okay, let's say my file text has gone outside file, but let's say this is file. I've written hello, how are you? Then you say, let's say again, hello, I am fine. Some text is written. You want to do a word count on this file using MapReduce. Let me see anybody has any questions till this point. Okay, no questions. Okay. Now I want to do a MapReduce. So obviously I will first save this file, copy to Hadoop, means to HDFS file system. Let's say this file is not big. This file is smaller than the block size or maximum 64 MB. Means I'm saying the entire file sits in one HDFS block, right? To keep things simple. Now, what mapper will do? Mapper will start reading the file from this offset. By default, I can write my own offsets. I can write my own delimiting functions, right? But by default, delimiters will be any white space, tab, space, any white characters will be can be used as delimiter, and by default it will look for offset of the line. So what it will do, map function will go read the entire block, means read the entire file into memory, right? And what it will say, it will break the file into key value pairs. Map will say hello, it will start reading from this offset and it will go one by one. Delimiter is white space. We can program our own delimiters on our own offsets, but I'm giving a very simple example. It will start reading from the left hand side. It will say hello, found a white space, delimiting it. Say hello happened one time. Then goes to the next part. How happened one time. R happened one time. U happened one time. It again goes to the second line. Map hello happened one time. It is not bothered about the last. It does not keep a record what it read last time. Every time it is just reading. It does not know what happened. I happened one time. M happened one time. Find happened one time. This is mapping. It is doing mapping. Key and a value. Now what it will do, right? In a simple case, right? Although there will be a lot of intermediate stages where it will do a sum on the map side, but let's keep that away and talk very simple terms. This map output will be given to a reduce function. How reduce function works? It will be a combination of key and a list of values. So what it will say? Reduce function will say reduce hello to. It will sum 111. It will say how 1 and rest all 1. They have happened only one time. So reducer is kind of doing a summation. It is reducing. It is taking the output from map and seeing what the common things are in a word count example, right? There could be n number of cases we might be doing, right? So simple key value pair. This is what it is doing. It will split the file according to the mappers, then do a mapping, and then it will do a reducing for each and give you a final output. Shuffle and all intermediate phases. For the time being, leave it, right? We will see that. So this is what I was explaining. Each HDFS split will be assigned a mapper. It will read it, do some logic on that. What that logic? It is important to understand. We will see in our MapReduce section. What is partitioning, what is sorting, what is grouping, and what is reducing. But time being, it is reading, doing some logic, doing a summation, and writing an output. So similarly, as we had in master slave for name node and data node for storage layer, we have master and slave for the MapReduce layer. We have a master which will be called job tracker, and we will have slaves which will be called task trackers. Let me denote by TT, task tracker. Task trackers will also run on data nodes, and task tracker daemon will send a heartbeat to job tracker. Like data node was sending a heartbeat to name node, task trackers will send a heartbeat to job tracker every 5 seconds. Data node was sending every 3 seconds, they will send every 5 seconds. So what they will tell, right? What they will tell to the job tracker. Now, When a job is submitted, where the job will be submitted, first of all, right? Let me clear the screen. I have a name node, I have a job tracker, JT, I have data nodes. Let's say 3 data nodes, D1, D2, D3. And I have a file1.txt, same example, which has some text, and I want to do a word count on it. Let's say this file is only of one block, and this file is sitting on this data node 1. A user submits a MapReduce program and says, I want to do a word count on a file called f1.txt. So first of all, what it will do, job tracker will go and contact name node and ask it where file.1 blocks are, right? Name node will say, it will reply saying it is on data node 1, right? Then job tracker will go and submit the job on the node where block is, right? This is called locality of reference, right? This is how Hadoop differs from traditional systems. Let's say in traditional system, MySQL, Oracle, whatever, I may have an Oracle client or a MySQL client anywhere. My server might be sitting somewhere else. Whenever I query, data is pulled to the client over a network. It is fine if I have small data, but in Hadoop, we have big data, large amount of data, terabyte, petabyte of data. So it is not right thing for me to move data to job tracker or the client which is asking. Better is I will go and launch my code on the node where data is. So what happens, whenever I submit a job tracker, the master daemon will ask name node, tell me where are the blocks of a file I need to work on. It will say it is on data node 1 or 2, wherever, and it will directly go on that node, launch MapReduce on that node, right? This is called locality of reference. So now I was explaining that it will be sending a heartbeat. All these will be sending a heartbeat to the job tracker. Task trackers will be sending a heartbeat every 5 seconds. So what they will be telling? They will be telling the task tracker what are the number of CPUs I have. What is the memory this data node have? Why it needs to tell job tracker? Because when a job comes and it is trying to submit on this node, it should make sure that resources are available, right? The system has RAM available. It should not be that this node is already occupied running other jobs. So this heartbeat every 5 seconds, job tracker updates with itself what resources each node has. Accordingly, we'll launch a map and a reduce job on the nodes, right? There are a lot of details, how much memory a map and a reduce will take, how many mappers reducers we can launch, which we'll see in cluster planning. But for the simple thing, this is how the communication path will be. Okay, Shiva is asking, could you explain the job tracker part again? Sure. Let me just clear the screen and explain this job tracker part again. So as I said, right, similar to a master and a slave, in a storage layer where we had a name node and I had data nodes, 3 data nodes. Let's say I have a job tracker, JT. What was happening here? Let me pick up a color, blue color. Blue color is a heartbeat for the storage layer means data node are sending a heartbeat or update or communication channel to the name node saying we are alive, this is the blocks we have, all those kind of things. Green color, task tracker is sending a heartbeat, the other daemon, which will be running on data node. So data node will have two daemons. One is task tracker daemon, blue color will be a data node daemon, right? Which is talking about storage. So both are masters. NN is a master, JT is a master. NN is a master for storage, JT is a master for map reduce. Now, what JT is doing, whenever a job comes in, let's say I choose a red color, a user submits a job, J1, to job tracker. Because it's a master, job will go to job tracker and it has to work on a file f1.txt which has a block, let's say sitting here on this node, data node 2, right? So obviously it can launch job anywhere. Let's say if I launch a job here, what it will do, it has to copy this block here to work on it. It will generate network traffic, right? Because block is here. So the best effort what it will do is, before launching a job, it will try to make the best effort to launch MapReduce on the same node where data is. How it will know where data is? It will ask name node. It will go and ask name node that I want to work on a file. Tell me the blocks of those files. Name node will say, right? Again, a lot of details. I'm not going into that. Name node will actually tell a array actually in reality, right? Which I will tell you later, which will be an array list saying this particular block you are asking is on data node 2, it's on data node 3, depending upon replication, it's on data node 4. So job tracker can go to any of these depending upon which is the nearest to it, right? Right. But for the time being, let's say it says this particular block is on DN2. So job tracker will launch, now knows that this particular block is on data node 2. But before launching a job, what it will do, it will check its table. What table? It has a table in which it says D2 has these many CPU cores, these are free, it has this much memory, this much is free. How it knows that? From the heartbeat. So task tracker is telling, daemon is telling periodically every 5 seconds to the job tracker updating, saying, although let's say it will say total I have 4 CPUs, but out of which 2 are used, so 2 are free. It will say I have 16 GB of total RAM, but only 4 GB is free. It will tell like that. So job tracker will know how many resources are available. So it will launch a job there. Accordingly, it will launch a job there, right? It will decide how many mappers, reducers it has to launch, which we will see. And accordingly, it will do that. Let me see if this is clear. Okay. So now, this is what it is doing. Task again, similarly here, same model. RPC, communication happens over RPC, right? Task trackers are constantly communicating, sending the resources information. Job tracker will know what resources each node has, where to launch a job, right? Let's clear the screen. Okay. So now let's come to the practical part now. Enough of theory. Let's start with cluster setup and see how things work. So Hadoop cluster has a name node, data node, job tracker, task tracker. A lot of other things can we add, right? As I said, it's an ecosystem, but we are just starting with storage and MapReduce. We can have Hive, HBase, Mahout, Pig, Uzi, Flume, lot of things, right? But these are the major things. which you need to for your cluster to be up and running, right? You might have a development team in your company, right, which might need to run a lot of codes and everything, right? For them to use the cluster, these things should be up. So you should know how the cluster is set up. So the cluster which we set up can run in three modes: pseudo mode, standalone mode, fully distributed mode. Pseudo mode is more of a dev environment. In what does it mean? I will just untar the Hadoop code but not run any daemon. What it is used for? Hadoop provides you some binaries, some libraries. What a developer can do, they can test out their code with that libraries, import into Eclipse and all, do a testing. But it is not running any daemon or a Hadoop cluster. You cannot run Hadoop command, you cannot store file, you cannot write file. It is just providing you libraries for your testing, only used by for development purposes. Second mode, standalone mode. It is run in a test environment. Means, let's say lab you want to do at home, you have only one box, one laptop at home. You can install all things in just one node. Your name node, data node, job tracker, task tracker, everything goes into a single node. Fully distributed mode is your production cluster. I will give a separate machine for name node, separate machine for job tracker, and I will set up maybe 20, 30, 100, 1000 data nodes. Data nodes will run data node and a task tracker. So now you know why we run task tracker on the same node on where the data node runs, because of locality of reference. So that it does not have to go across node to fetch data. Job tracker will try to best to submit a job on the same node where data is. So that's why every data node will have a task tracker running. Now, some important Hadoop configuration files. We'll come to these slides little bit later. Let's go to system. So first thing, what we need to set up a Hadoop cluster. First of all, you need minimum Java 1.6, right? You need Java 1.6. Why you need Java 1.6? Let me see, we have developers here. Okay, I think Ronak, Minakshi, Pawan. We have three developers here. Can anybody answer this question? Why we need JDK 1.6 for running Hadoop? Why not any prior versions? Or I know you people are not, you people are not from Hadoop, but can you think of any reason? What could be the reason why we have to have a JDK 1.6? Okay, in the meanwhile, people come back with an answer. So we need minimum JDK 1.6. I will explain you why we need. We need any Linux flavor. It runs on Windows as well, but in production, no. Any Linux machine, and then I will look at all this configuration file. So I've put this in the slide so that you can see and refer it, but I will show you on the system what it is. Okay, I've not got any answer from anyone. I'm not sure people are there or not. Are you guys there, everyone? Pawan, Minakshi, Ronak. Okay, okay, great. Okay, so any guesses what could be the reason why JDK 1.6? Okay, not a problem. So I will explain you this. So similarly, this slide is for HDFS layer. This file is for MapReduce layer, where we have to set up a job tracker and a task tracker, right? So let me explain you this on a system. Let's start a node. Don't worry what I'm doing. I'm just removing my USB controller from my virtual machines. So I just want to make sure my mic, which I'm talking to you from, does not connect to my virtual machines. Otherwise, my volume will go off, right? So you don't need to worry about this. I'm starting my virtual machine, right? So I've showed you yesterday how to set up VMs. So let me start one machine here. Let the machine come up, and I will explain you the reason why we use JDK 1.6. So for example, every Linux flavor, doesn't matter, Ubuntu, CentOS, Fedora, whatever you use, comes with OpenJDK, right? OpenJDK. I can use this to run Hadoop, not a problem. But problem will start coming when I start submitting jobs, when I start submitting multiple jobs. They will fail if my node does not have high resources. Even in production, we will not use OpenJDK. We will always use JDK minimum 1.6. So what is the reason? How Java works? Let's say I create a JVM, which is Java Virtual Machine. Let's say I give it JVM some memory, 1 GB, 1 gigabytes of memory to a JVM. Whenever we submit any job to a JVM or run any code inside a JVM, it forks a sub JVM to run that. Correct? So the moment this fork happens, it copies the entire environment to itself. So what it does, if I have given 1 GB to the JVM, a parent JVM, when the fork happens, at that very instance, it will immediately ask me for 1 more GB, right? If my system does not have 2 GB, it will crash, right? But let's say it has 2 GB, it will immediately ask for 1 GB and then go down to whatever it needs. But during the fork time, it will ask exact replica of what it was initiated with. So this has been rectified from JDK in the JDK versions 1.6 and higher. So all those guys who are from Linux background, Linux fork a process, sub process. They're called lightweight processes, LWP, because their forks are not very expensive. So in JDK 6 and higher, whenever a JVM is created, let's say with 1 GB, and I submit a job which forks a child JVM, child process, it will not ask me for 1 GB, right? It will not fork a 1 GB one. So my system will not give oops, means out of memory errors. Another reason, this is the technical reason why we don't use anything else. Other is, there is a command called JPS, Java process command, right? Linux has PS command. So there's another command called JPS, which is available only from JDK 1.6 and higher, not before that, right? So there are the two reasons. One, a technical reason for JVM fork, and another is we don't have a command available which can just list us the Java processes. Otherwise, what we have to do, I have to do PS, AUX or -ef grep on Java to see what Java processes are running. But I can use directly JPS. It will list me only Java processes. Because Hadoop is written in Java, I'm only worried about Java processes. Okay, now I think my virtual machines have come up. Okay, let's see. Now let me connect to my virtual machines and set up Hadoop on it. So I have one server which is called a repo server. As I was talking to you yesterday, what it does, I have all packages in this server. Means my Red Hat, Linux, RPM packages, anything I need, I have dumped it here. I don't need to go to internet. Hadoop packages, everything, right? But let's say for the sake of the class, where we will download packages from. First thing, go to Google, search for JDK, anything greater than 1.6, 7, 8, anything you can use. Go here, download from Oracle side, JDK, right? You will have different versions here. You say accept the license. So I am running, so it will tell me which JDK you want. If your platform is 64 x86, which platform you have, right? We will be using Linux 64-bit one, right? Download the JDK 6.u45 or anything higher than 6, right? This means 1.6 update 45. I can use anything higher than 6. Any package you can download. Second thing, Hadoop download. It will take me to Apache Hadoop releases site. Here you will see lot of releases, right? 2.7 is the latest one, but we will always go for stable. But currently we are doing with Hadoop 1. We will go to Hadoop 2. Later, right? So what I will do, I will click on the mirror link, click on any link which is nearest to me, or you can click on any. Here you will see directories. You will see latest versions and all. Always choose the stable. Stable 1, stable 2, stable Hadoop 1. It is 1.2. I can choose an RPM, I can choose a tarball, my wish, right? But I will go by tarball because it is easy for you to understand where files are going, what files we modify. If I simply put an RPM, right, from a learning perspective, it is not good because it will set up a lot of things for you automatically. So we will go in the manual way. So what I will do, I will click here. So the moment I click here, what happens? It is asking me to save. I can click OK. So it will download the package in my base machine, right? Your wish. I can download that way, copy into my virtual machine. But what I prefer is I copy this, complete the path, copy the entire path, go to my virtual machine, and I say wget here. Let's say I say wget means webget this path. I'm directly downloading inside my virtual machine. I hit enter. Currently the command is not installed. Right, so in your case it will be the installation which I showed you yesterday. Wget will be available. Mine is a minimal install, so that's why that command was not there. So I say wget, hit enter. So see, it will start downloading the package directly in my virtual machine. I'm canceling it because I have already have that package forehand with me, right? Clear cd, and I clear the screen. ls-l. I've downloaded the package in advance to save on time. File size is around 80 MB. Hadoop package is around 80 MB. So now the Java package which I download, I can either say rpm-ivh install on that package, right? Or I can do a yum install, right? For example, let me show you this cd virtualization data cloud setup scp jdk 745 root 192.168. I have downloaded a package in my base machine, but I'm showing you what options you can use to install it. Right, so it is copying the package in my 70 IPs of the name node one, NN1, one machine which I've given. So for the time being, it is just a host name. It is not behaving like any name node or data node or anything. So now that package is there, right, in my virtual machine. So what I can do, I can do rpm -ivh jdk install, right? It will install for me. Or what I have done is I have copied this package in my repo server. You see here, this package is in my repo server. So I do not need to worry about going to internet, downloading every time. I've just set up a virtual machine which is acting as a repo server for me. All packages are there. So now the IP of my repo server is 254. And whenever I need to install anything, what I do is I simply say yum install the package name, hit enter. So it will go to that server and install for me. All those who are not from Linux background, so how it is happening is there's a file cat etc yum.repo server.repo. Any file with the name .repo, you can give any name, doesn't matter, under this directory. I cat this file, so you see the path where I have copied, right? So this is my server 254, the path, right? So it is picking from there. So I say yum install, or you can do a manual install by rpm also, your wish. But as I was telling you, we will be keeping our setup as close as to production, how things happen in production. Let me see if anybody has any queries here. Okay, no queries. Okay, so now see the package which I have downloaded, right, in my, which is in my yum repo. Obviously it is not from Red Hat, so that's why it's giving me a warning message, correct? So I can say a skip option there as well, right? While I'm installing, see it is saying not signed. So I can say here to not to check for keys, no GPG check, right? So it will start installing. I'm saying do not worry about the signature, I'm fine with the package. I know that it's from a reliable source because I downloaded it from Oracle, right? So it is installed. Now Java is installed. See, installation is complete. Where it will install? RPM, like, oh, I know from the top of my head that it went to user Java under this path, right? So you can see it is installed here. But if you don't know where it went, rpm-ql, the package name, it will tell you the path where that package went. rpm-ql, right? It will list you all files where it installed. So you can see it is telling user Java. Their command is rpm-ql jdk, query list jdk. So it is listing me, it went there. So now ls-l user/user Java. In Java, this is where it is installed, and you see it is a symlink to the latest one automatically by default, right? So here you will see all the Java installed. Inside bin you will see binaries, and there's a command JPS also available. which is not available prior to 1.6. So I'm doing an ls on the path, correct? So now if I say which Java here, it is telling me user bin Java, which has come from OpenJDK by default with every Linux. My Java is installed where? The new package which we put is installed in this path, JDK 1.7 underscore 45, right? And there is a soft link to that which is called latest. So now what I have to do is I have to export the path. One thing, first of all, to make use of the new Java, right? So before that, I'm logged in as root. I can run a software with a Hadoop user, with a root user, but the problem is it is the privileged user. So if that user is compromised, my system will be at risk. So never run any application, whether it's Apache, MySQL, anything. It runs with its own ID. So you can create any user. Let's say I create a user called Hadoop. Currently the user is not there. ID, I'm checking that user, it is not there. User add, I say Hadoop, adds a user for me. I again execute the ID Hadoop command. I can see the user. It has created a user for me. Now set a password for it. Any password you want. I'm setting Hadoop only. ls-l/home directory will be created for this user. Blank. Nothing is there. Now what I will do, the tarball which I have downloaded, I will untar that into that path, home Hadoop. Scroll the screen up. I'm saying this is a command tar-x extract the compress verbose file name hyphen capital C means to this path. Hit enter. So I'm saying untar the Hadoop tarball which we downloaded under /home/Hadoop. So if I do ls here, you will see it has come here. But now the problem is owner and user and group is root. Why? Because we untarred by root. So what I have to do? I have to do change ownership. I have to change owner recursively to Hadoop, right? Because home directory should be owned by that particular user. Fine. su-hadoop. I will change as that user. Logged in as that user. Let me exit. I am currently as root. How to go as that user? su-space Hadoop. I am logged in as that user. It is my wish I can use this name 1.2.1, but I might find it difficult to type these names every time. So what I can do is I can give it a short name, kind of an alias. For example, Gurmukh is my name. My alias is Aman. So people find it comfortable to say Aman. So instead of saying Hadoop -1.2.1, why not call it just Hadoop? So I've created a symlink, right? So I do ls-l Hadoop. So it is listing me all the files. This is same as ls-l Hadoop. Same thing. It is just an alias. So it makes things easier for me to type. Also another reasons are there which we will see when we do upgrade. I will just change the symlink to a newer directory and I don't need to change the path. Now let me show you the directory structure. Hadoop, what it has? It has a bin directory which will has all the commands. It will have config directory which will have all the configurations. It will have some documentation, libraries, some jar files, right? Other some directories, right? I will explain you what all these are as we go. Some another directory which will have some system commands, correct? So now if I say Hadoop, for example, hit enter, it says there's no such command, right? Where is this command? Inside Hadoop directory, there's a bin directory. Inside there is a Hadoop command. It is working now. See, so ls -l Hadoop /bin. See, there are all these commands here. So what I can do is either I have to always type the complete name, Hadoop /bin/Hadoop, whatever I want to do, fs-ls, something like this, correct? Which is not convenient for me. Also, when I say which Java, it is picking some awkward Java. But I know Java which I have installed new version, it is at this place. So what I will say now, I will open the bash profile of this user and I will create an environment variables here. What environment variable? I will say export java_home is equal to /user/java/latest. Export Hadoop _home is equal to /home/Hadoop/Hadoop, correct? This is the home directory. Under this which I have created a symlink, right? And now the path becomes path is equal to $java home, the variable /bin colon $hadoop home /bin and any old path which I might had, right? I'm including that into the path variable and I'm executing it again. I can either log out and do that, or I can do that. Now if I again do which Java, it is picking up the new Java. Now I say JPS, it knows now. I say which JPS, it is telling me the path. Now it is able to find a command. Similarly, which Hadoop, now I say, it is able to find the command. So if I say Hadoop, it will run a command for me, right? So these things are set up now. Now what other things I need? pwd cd Hadoop directory. I'm sitting in the Hadoop extracted directory. I will go to config directory, cd conf directory, ls-l. Here you will see path is config directory. I will see multiple files. Each file has a role, but we will take one by one as we go along. First file is Hadoop env file, right? Hadoop environment file. Okay. So let me just copy bash profile this path Java home. I'll show you why. So here what I will do, I will open this file hadoop env.sh, Hadoop environment file. In this, it is asking me where Java is. I am setting Java. I'm telling to Hadoop where to find Java. By default, it will look at this path. Second thing, I do not need to change anything else, but you guys at home might be running system with lesser memory. So this is what I was talking about, JVM. By default, as Hadoop is written into Java, every daemon I start will create a JVM. By default, it will give me 1 GB of memory. My cluster is not that big, I do not have that much data, I can reduce it. Put 300 MB JVM size. After this, I do not need to do anything. It will come up, right? But I can write some other things, modify for my easier use. For example, where Hadoop should write it process ID. So I will say home slash Hadoop. I'm saying inside the Hadoop home directory, create a PID file where you will write your process ID. That's all. Only three things we have modified. Java, that is mandatory. After that, if you have more memory, you don't need to modify Hadoop size, and it is your wish where you want to write your PID. Second thing, another file, important file we have to modify is core-site. Right? So what core-site file tell? This is the file, as the name says, core file of your Hadoop system, which will tell about the name node, some properties about HDFS file system. So this, all these config files are XML. If you note, other than the environment file, all files are XML files, right? With the exception of few, I will show you what those are. So each file will be an XML file. So I open this file. Each XML file has a starting tag. It will have a global opening and a closing tab, which is a configuration tab. What it will say? It will have a property opening tag and a property closing tag. Right? Inside that, it will have a name, opening and a closing tag, similar to an XML, right? And a value opening and a value closing tag. Some values I am telling it. Right? Now, what values I will tell it? Right? What values I will tell it? So, in this is core-site file. So, global configuration opening closing tag. Each property will have a value and name and a value associated with it. So I will say how the combination will be. Each property will have a name and a value. So what a name will be? First of all, let me show you my GitHub. So you don't need to worry about noting down anything. This is the link which I have shared with all. Right? So you go here, you will find all things which we do in class. Do not need to worry about anything we talk about. Configuration files, everything you can find from here. Parameters, I've given the exact things, right? But let me explain you things here one by one, right? So but I've opened this file for you, core-site.xml, right? So what it is telling me, file systems default name node, right? It is telling me my file system's default name node is where. So I have to tell whichever node I have to run as my name node. File system is HDFS. I'm saying nn1 dot cluster 1 dot com. I can leave it here. By default, port will be 8020. But if I want to track, open firewall, all those, I can give a explicit port. So I'm saying start my name node daemon, which will start on this node port number this. Which is this node? I can give the IP also here. This is this same node where I'm sitting. 70. So if you have not configured DNS, for example, you can simply give the IP here, whatever your system IP is. Save. Second file, hdfs-site. This file will tell the concepts which we have talked about. For example, where name node will store metadata on the disk when it needs to persist. Means fs image edit file where it will store on the disk. Right? Same opening closing tag, but to save on time, what I will do, I will simply copy it. Go to hdfs-site. Let me show you on the system. What will happen? I'm saying property opening and a closing tag. I'm defining a value. I'm saying dfs name.dir means distributed file systems namespace directory /data/name node, where it will be. Right? So currently we are setting a single node Hadoop cluster. Right? So this parameter is for name node. Right? So let me stop here, and data node we will check little bit later. So what I said, this will be the path /data/name node. So what I have to do, I have to create a directory by this path. Right? This could be a directory on your operating system hard drive or a separate hard drive. In production, we will always give a separate hard drive. I will not put this on the same hard drive on which my operating system is installed. Why? Because HDFS have a tendency to use the entire disk available given to it. So I will run out of space for my operating system. But in test environment, you can do whatever way you want. So what I have done is, I have created a separate hard drive partition. If you look, my operating system is installed in SDA. I've created a one more partition, STB, and given it a mount point at data name node. How we create a mount point and all those who are not from Linux background, we will cover this in our cluster planning session, right? How we will do that. But for the time being, what you can do is, you can simply create a directory mkdir -p and the directory name /data/name node, this directory, and make sure the permission of that directory is owned by Hadoop, so that because we are running cluster with Hadoop, oh sorry, I have to run it as root to change the permission of that. Correct? So I do ls-l/data. So I can see there is a directory called name node whose owner is Hadoop user. Currently empty. Currently empty. So now what I will do, Hadoop, right, which path we have set up, Hadoop name node -format. I am formatting my name node now. I hit enter. It says yes. I say it is asking me, are you sure you want to format this directory? I'm saying capital Y. Do not give small y. It is capital Y. Right? So it is saying has been successfully formatted. So now let me go back. So I showed you this directory was empty, but all of a sudden two files are created inside. Two directories are created inside that. What are those two directories? Image directory will contain fs image, the original fs image when you format your name node. This image will also be copied fs image to a directory called current. Right? Two directories, image and current. Image directory will have an fs image, original fs image. When you format it, this will be copied into current also. Current will have another file edits, which is your journal, to which all the changes will go. Fs time is the time when your name node was formatted. It will contain that, right? So let me show you these files. Important file is version file, cat. You see this namespace id? This is what I was talking about. Whenever you format your name node, it will give you an id, a random number. Every time I format, this number will change. So currently my cluster is new, I do not have data, so I do not have any issue in formatting. See, the number changed now. Initially it was 6 8 something, it has changed, right? So the logic is, I will execute this format command only once in the lifetime of the Hadoop cluster. If I format it again, my metadata is gone, my cluster ID is gone, my data node will not be able to join. There are recovery methods we can do, but you should not format the name node ever again. Once you start your cluster, your data nodes are talking and you are writing your data, you will never execute the format command again, right? This layout version is, what is the data structure version of your fs image? -45. Lower the number, higher will be your Hadoop version, right? This is kind of a reverse part. It is -41. If I see -56, it means I might be using Hadoop 2.2 or 2.6. Lower the number, higher the version. I can go from -41 to -50, but I cannot go from -41 to, let's say, a number which is lower than this, -30, right? So format is done. Another files are time, right? So this is a time when the name node was formatted, and I cannot cat fs image and all, because there will be binary files, right? I cannot read them directly, but there's a tool to reading that. We'll come to that later. Now jps I do, name node is not running. Why? Because we have not started it, we have just formatted it. So how will I start? I will say hadoop-daemon .sh. This is also coming from same directory, which same path. So I will say hadoop-daemon .sh start name node. See, it is saying starting name node. I do jps. So now it is giving me some error. It has not started. So why it has not started? We can look into the log. So log is tail hyphen some number, you can give 20f Hadoop logs directory. In this you can see log, right? So this is the log which will tell you the process what your name node is doing, right? What starting, not, and all those kind of things, right? So now so what things we have done: pwd ls-l cd hadoop config directory, clear vi core hyphen site nn1.cluster1.com, vi htfs hyphen site, right? So all these are available in this part, right? Now let me tell you one more thing before we move ahead. vi hadoop env.sh user java latest heap size. Okay, okay, let me just check why the new node did not come up. Start new node. Okay, okay, just a second. What has happened there is I was using this for another purpose. Okay, let my machine reboot and come back. So this is what I'm explaining in the slide. So we have environment file for setting the environment variable, core-side mainly for name node, HDFS for storing where on the HDFS where the metadata will go, mapped and master slave files I will let you know what they do. Minimum what we need is JDK, any Linux box. I will set up the environment. I will set up Hadoop environment, Java home, heap size. I will set up core file. I will set up the HDFS property file. Right? So your name node is up. So it will show your process. So initially why it was not showing, it was running, but it was running in the background. Why? Because I already had one Hadoop instance running here before uh, the class. So I deleted it while the name node was running. So you'll see the name node process is up and running. So I can access this name node from a browser also. I can enter this from IP 192.168.1.70 port 50070. See, this is my name node. Currently, it is showing zero capacity. Why? Because data nodes are not there. Data nodes are not there. Same thing I can see from the command line dfs admin -report. Right? Zero capacity. Why it is giving this message? Hadoop underscore home is deprecated. So what happens from version to version? Some variables change. It does not mean that Hadoop will not run. It is not error. It will give you warning. But if I want to remove this warning, I can do export Hadoop underscore home underscore suppre suppress underscore one is equal to I can set this spelling. Oh, it is right. So it is gone now. So you will not see that warning coming, which was coming Hadoop home is deprecated. So I can suppress the warnings by putting this variable. I can put this variable permanently in my bash profile so that I do not get any sort of warnings. Now I cannot write any file to Hadoop. Why? Because only my name node is up, not data node. Data goes to data node, right? Only name node is up and it's saying zero capacity. So I have to set up a data node also. I have to tell which is the data node where data will go. Correct? So what I will do, we are doing first the standalone mode configuration. So I will go in this file again. I will open vi hdfs file again. And now what I will do, now I will say one more line here. Instead of saying dfs name.dir, I will say data.dir. We are running standalone mode, right? In which name node and data node are running on the same node, but actually in production it will not. We will go to distributed mode little bit later. I have given a path. Correct? Save it. I say mkdir -p data node. I create that directory. I change the ownership of that directory to Hadoop. Change ownership recursively Hadoop :Hadoop, right? And I go back, right? My JPS name node is running. I have to start data node now. So same command which we have used to start the name node, but now instead of name node, this parameter will become data node. I do JPS, data node is up as well. Now, if I do report command, it will start showing me data node, right? It will take some time because data node is registering and all, right? It will take some time for it to come. So I've started the data node daemon. So a registration process is happening. So it is looking in core-site file, knows where my name node is. Currently we are running both on the same node, so it is not a problem. But when we run distributed, you will see how they talk. So now see, I can see one node now. It is telling total capacity is 8.5 GB. Why it is telling 8.5 GB? See, my hard drive is 8.5 GB. I've created a directory. Slash data name node is on a separate mount point, but slash data is on my root partition. That's why it's telling 8.5. So it will think the entire thing is for me. So if I go to browser, I refresh it. See, one name node is started coming here. If I click here live nodes, it will tell me nn1, means nn1 is also a data node. So now let me copy some file there. ls-l, let's create a file. vi test underscore file. This is test file. Correct? ls-l is doing listing my local file system. Hadoop fs-ls is listing my Hadoop file system. How it knows that? By default, Hadoop, when we invoke, it will go to Hadoop file system. How? Because of a file which we have set up in core-site. If we cat core-site file, here I have told where my name node is. Correct? So it is taking that parameter, whatever I've written here, from that it knows where my name node is. So it's doing something like this. It is the same thing. So it is not explicitly, we do not need to give the complete path. It automatically takes from the config file. But let's say I'm listing this local file system and I want to list the same file system from Hadoop command. So I can say file colon 3/. Right? So it is similar to ls-l, sorry, of my base system. Same thing it is doing here. Correct? So it knows where I have to go. By default, Hadoop always goes and talks to Hadoop file system, not native file system, right? So it will go for Hadoop. So now my file is this. I can copy this file Hadoop fs. I do not need to remember command. I hit enter. After typing Hadoop, it will tell me what all options I can give. If I want to do any file system operation, I will use fs, right? Fs command, and each command will have an option. I hit enter. Again, it will tell me what options it can take. It can do ls, it can do a recursive ls, it can tell you du, it can copy, it can put, right? Lot of things. So I do not need to remember any command from the top of my head. So I say put file name, whatever the file was, to Hadoop. So now I do ls on Hadoop. I can see the file. This file is on Hadoop file system. Cat, right? Now I am running name node and data node both on the same machine, right? Where my name node is writing metadata slash data slash name node current. See, edits has grown. Initially, if you remember, it was around 4 bytes. If I give human readable form, see, it is telling me 1.1 MB. It is not the size of the file is 1.1 MB, which I have written test. It has to do a lot of metadata, rollback, lot of information it will store. FS image is 1.12 only, right? And the file which I have written, where it has gone? It has gone to data node, right? So when we started data node, we did not format it. But if you look here, this data node file will pull the version file from the name node, and it will have the same ID as the name node has. Same number. So we are formatting only the name node. Data node goes, registers. If it was blank or new, does not have a namespace ID, name node will give it the name node ID, and then it joins the cluster, and it will get a storage ID. This storage ID is used for that block to data node mapping. When a name node sees block B1, how it will know which data node it has come from? It knows from this string. IP is there. It knows that this particular block is coming from this node. So it builds a map with itself. Now the file which I have written, which is this file, as I said, from a Hadoop perspective, it is a block. But I can simply go on the lower file system and simply look at this file. It has gone to data node. I can cat this file. See, Hadoop sees it as a block, but that block has to go to a lower ext3 layer. I can directly go and cat that file, right? But I cannot modify that file because MD5 meta, this will change and it will corrupt the block, right? So now I can also say Hadoop fsck slash. Currently I do not have much data, so it will not take a long time, but it is giving me a message. See, which I was telling you, under replicated block, which block, one block we have copied, it is saying it is under replicated. Target replica is 3, but only found 1. Why? We have only one data node, and by default replication is 3. We do not have 3 data nodes, so it will give me a warning. So I can reduce the replication explicitly, right? So we'll see all those things, right? So it is giving me a warning. I can see where the file went, right? For example, the file name was test underscore file. I can do a lot of things on a file. I'm doing an fsck on this test file. It is telling me the size, everything, replication 18 bytes, right? Total files 1. How many blocks it has? 1. Minimum replicated blocks, default replication, corrupt blocks, everything it is telling me. I can say hyphen files hyphen blocks hyphen location. It is telling me what is the length, what is the replication. I can say rex. So it is telling me the IP also, where it went. Right? See, currently I have only one data node, but if I would have many data nodes, it will also tell me where the blocks of a file went. So it's saying this has only one replica and it went on this node. Currently we have only one data node. So we will see all those things. So question from Shiva is there any reason the HDFS is not created directly on the raw disk instead of mapping? See, thing is, the reason is, if we would have to go by that way, we have to change the architecture, right? As I said, Intel platform does not support block size greater than 4 kilobytes, right? So I cannot directly write there. If I have to write, then again that same problem. In Hadoop we are talking about larger data, terabyte, petabyte of data, and if I start writing that big file and breaking down into 4 kilobytes, it will impact my performance, right? So that's why we created HDFS to sit on top of it, which can take larger blocks. At the lower layer it takes the smaller blocks. And another reason is HDFS file system will be spread across nodes. As I was explaining, your local file system will be very specific to a node, but in HDFS what will happen? One node, two node, three data nodes. The moment I create HDFS, it is spreading across the entire cluster pseudo file system. I may have ext3 here, I may have ext2 here, I may have ext4 here, right? So that is the reason, distribution. So data node is up. Now let's go back to, this is what I'm explaining in my slides. Right? This is what it does. You can access each from the UI. So for example, I can see a block scanner report, which I was telling you. I refresh it. So what data node is doing, see the percentage, numbers are changing, progress time period. It does not have much data, so I don't need to worry about here. So it will not take time. So it will be doing a block scan and it will send a block report every hour. First time it sent, then every hour. So you can see when is the next one, progress, right? Now the question might be, another question might be, you might ask me why I'm accessing name node on 50070 when I have given in the config file 9000, right? This 9000 is an RPC port to talk between name node and data node, right? But this port which I'm telling you is a web server port. Every daemon will have a web server built into it. So using which we can access what they are doing, and data transfer happens using REST APIs between two web servers. So if any daemon does not runs a web server, I cannot transfer a data. We don't need to take care about this. It automatically starts with the daemon, right? So this is what the basic is. Now, cd hadoop config directory vi hdfs hyphen site. So as I said, I'm starting my cluster. By default replication is 3. I have only one node, so it will always keep on giving me warning. So better is I should reduce this replication. So how will I reduce this replication? I can set dfs.replication is equal to 1, right? If I do not set this, by default it is 3. So whatever config parameters I give, it is overriding the default parameter. So now I said 1, save it, right? And I say hadoop hyphen dfs dot sh stop data node, right? Stop name node. Actually, we do not have to stop name node, but we have configured both on the same, right? So that's why I'm doing a restart of both for parameters to take effect. Otherwise, we don't need to restart name node. So I'm restarting the cluster, so it reads the new parameters. Now let me show you one more file. Vi new underscore file. This is new file. Save the file. Hadoop fs hyphen put new file. Okay, it will take some time. It is saying name node is in safe mode. We'll come to this detail. So I've restarted name node. So let me show you data node, name node, current. See, it got reset. So what it did was, why it is in safe mode? Because it was doing this emptying. It was emptying edits, reading, committing to fs image. So that's why it was in safe mode, right? So we'll see the details of that. So now I copy it again. It has come out of safe mode. So now I do hadoop fsck on this file. It is not saying me under replicated. See, default replication is telling 1 and file is there 1. It has no problems. But if I do it on the other file, which was other file, I forgot the name, test underscore file, right? For it is will still give warning, because that file was copied at the time when replication was 3. So it is expecting to see 3 blocks. But for the new ones, it will not, right? So there are a lot of details here. How we will change a replication of a file which is already there. How can I change a replication at a file level? For example, my config file might say 3, but I can set at file level 1, 2, 4, right? Those kind of things. So we'll see all this detail as we go along. But this is a very basic Hadoop introduction, like how to set up name and all. So this is single mode. I have set up everything on the same node. So I can quickly start cd hadoop config a job tracker also. Now core hyphen site and hdfs hyphen site. These two files are for storage layer. Name node, data node. Mapped hyphen site is for your MapReduce layer. So I open this file, and here I will say where my job tracker will run, or where my job tracker will run. Right, to save on time, I will just simply copy the parameter. So I have to just tell where I will be running the job tracker. So I'm saying my job tracker is running on the machine whose name is NN1. In our next class, we will see our full distributed mode. But currently I'm saying it should run on a node whose name is NN1. I've given a separate port, 9001. Save it. Right. JPS. Now I say start job tracker JPS. See, job tracker is up. I say start task tracker. Task tracker is up. This is my single mode. Right. So how I test whether actually my MapReduce is working or not? Right. So how we'll test out? Let's say I do Hadoop fs-ls or mkdir. Let's create a directory on Hadoop file system. Spelling wrong, typo, mkdir. Right. I've created a directory ls created one directory. Correct. So let me delete or let's say we have these two files, Hadoop fs hyphen put new test to input. I'm copying these two files to an input directory. See, these two files are copied there, and we know what they contain, right? New file, test file. This is a test file, this is a new file. So let's say I want to do a word count on this quickly, right? So how will I test whether my MapReduce is working or not? So by default, you can write your own Java code, but by default, to there are a lot of test jar files available with your Hadoop cluster, which will let you run examples. Lot of benchmarking tools, right? We will see all those in performance tuning. So when we set up a Hadoop cluster, when we go to a distributed mode in a production, it is not that after just starting the daemons we will start putting data. We will do stress testing for file system, for MapReduce. We'll do benchmarking, what is the throughput, and then we will certify the cluster is fine for production. How we'll do benchmarking, we will also cover in the course, right? So now, as I was showing you, we have a jar called Hadoop jar. So this is a Java jar. So I can use this jar, Hadoop, this jar. I can call, if I hit enter, it will tell me lot of test examples it has, or they are actually classes, right? I can call word count. I'm saying word count on what? Input, which is on Hadoop. And I'm saying write an output. Hit enter. So what it will do? This word count will go, see, two input paths to process. Why? There were two files. It is running map phase, reduce phase. 0%, 0%, right? So first mapper will complete completely 100%, then reducer will start. So it will not take long because our files are very small. Map 100, then only reducer will start. Reducer 100, now our job is done. So it will give you counters. These are called job counters. What are job counters? It will tell you how many bytes it read, how many time it took, what file it wrote, right? All those. So we will all see all this as well, what each value means. But for the time being, Hadoop fs-ls it created an output directory. What it will write in output directory? Hadoop standard is, if the job is successful, it will write an underscore success file. It will write it logs and it will write the output file. Part name will always be part hyphen R or hyphen M. How the name will be decided? If this file was written by a reducer, it will have R. If file this was written by a mapper, it will have M. So why reducer ran here? Because we are doing word count. Because it will do count word, then do a summation as I showed you in the whiteboard. So it is reducing. That's why reducer phase kicked in. There might be cases where reducer phase might not kick, where we might have unique sets, right? These are, there's a number how many files it create depending on the size. So I will do a cat here. See, cat new cat test. See, you can count manually. Capital this happened only once, small this happened only once, is happened twice. It was in both files, so that's why it gave as. File was also in both file, so it is 2. New happened once and test happened once. It is doing word count. So our cluster is up, HDFS is fine, MapReduce is fine, everything is fine. So this is a single mode. So please practice till this point, really very important. Reach out to me because we will be meeting after 1 week. Drop me email if you have any issues. You should be have an understanding of what we are doing here, right? We will go to distributed mode. I will explain you each parameter in detail, what we are doing, right? So you can go and refer my GitHub, Hadoop 1.0. Inside this you can have config file, copy paste, and things will work for you, right? Just set up a virtual machine, understand what HDFS is, how we are copying file, how we are running MapReduce, setting daemons, right? And from here we will build on. We will take these files which I've told you, right? I have not explained you anything in the files currently, right? I have not explained you even in the core-site file what all parameters can go. When I say HDFS-site, when this parameter was not there, I was saying replication is by default 3. But where it is picking from, it is not in this file. Where that default parameters are coming from, all those things we have to look for. Can I write this to multiple locations? Can I write this name node also to multiple locations? How will I do round robin? How will I take care of redundancy, right? All those things we will see, all these parameters, right? A lot of things are there. So please go through that. I will share the video recording session through email. I hope you have downloaded yesterday's one, because I shared that through an email, the link and all, so you can download that. I will share today's recording as well, so you can download it. So guys, thanks very much for your time. If you have any questions, let me know, or else we will close this session and we will meet next Saturday. So I've given you a few commands which we can run, and we will be talking in detail. So you can refer my GitHub. I've given here my GitHub. You don't need to worry about copy everything from there. You can, and I will take care of your concepts. To further reading, in next class we will be setting up our Hadoop cluster in fully distributed mode, going at each parameter one at a time. We will look at how this replication is actually working, how 3 1 is decided, whether name node decides replication or data nodes decides a replication, right? All those things we will look into that. So thank you very much, Rohit, Ronak, and Shiva. I can see you guys are still there in the session, right? Others, most people have dropped out, right? So thing is like it might be getting late, and people also think that anyway the session will be recorded, so we can see it afterwards, but I have no problem, right? So please feel free to reach out to me with any questions you have. It might be related to or how dummy it might be, not a problem, right? I will share the recording, go through it, set it up once, get a feel, because this is a base for everything what we do from now on. Hadoop cluster will grow very big from now on, right? I have, as I was telling you, I have a lot of nodes. So I will keep on adding nodes, building a cluster, running multiple data nodes, keep on adding components. And if you don't understand what we are doing initially, it will be a problem, right? So thanks very much and have a nice week ahead. And I will see you on next Saturday, 8 p.m. Till then, happy learning Hadoop. Good night. Bye bye.